In the last video, we looked at neutralization reactions and how they are the same and different when our reactants are strong or weak. Whether our reactants are strong or weak, we make water and a salt. Whether our reactants are strong or weak, we write it as a one-way reaction because making water from acids and bases or hydrogens and hydroxides has a very, very large K. When you're doing calculations for these, whether they're strong or weak, it is stoichiometry. The difference is how we deal with the solution after. When it's a strong with a strong, our solution is neutral. We make water, and most of the other ions are spectators. When it's a weak with a strong, or even weak with weak, we have some ions at the end, like this A minus, that is itself a weak base or the conjugate of a weak acid, meaning that it can impact the pH of that solution that we have made. So what we're looking at here is not our initial reactants, but the products that are made or what's floating around in the water. We're focusing on the ionic salt and how that ionic salt reacts with the water. That reaction is often referred to as a hydrolysis reaction, and it's based upon the salt and what sort of ions the salt is made from. Some salts, remember, ionic compounds, are neutral. These are salts that are made out of cations and anions that don't have the ability to react with water, specifically to hydrolyze water or to change the pH of water. And they don't have the ability to do that because those ions themselves are not very strong or are negligible in their strength as acids or bases. Chloride is a great example. It's the conjugate base of HCl. Because HCl is so strong, Cl minus cannot accept a hydrogen ion back. That means that when you put Cl in water, it can't react with it, or it can't make the water break into hydrogens or hydroxides. Sodium is similar. It cannot go back with the hydroxide, making the water break back apart. So whenever our cation is one from the first two columns from a strong base, or our anion is the anion of a strong acid, those ions are so weak in solution that they become spectators and don't do anything to the water. It's when our cations and anions come from weak acids or weak bases that they react with the water themselves. So when I have a weak acid like hydrofluoric, acetic, or phosphoric acid, the conjugate base of that, which is an anion there, acts as a weak base. A weak acid has a conjugate that's a weak base. That salt, or the thing that it includes, the salt, that includes that anion, then reacts with the water. So whether it's a fluoride, an acetate, a phosphate, or any other anion, that will act as a base. That means that it accepts a hydrogen ion from things, or it turns back into HA, and as a result, makes water act as an acid, producing hydroxide ion. That establishes a new equilibrium, and the hydroxide ion will raise the pH. This reaction is very important. It's not, if we go back up here, this reaction that proves that the pH is above 7, because neither of these things change the pH themselves. It is what they do with one another. When the A minus, when the anion reacts with the water, it then produces hydroxide. We can also have salts that are acidic, and that's when we had a weak base reacting, because the weak base will turn into a weak conjugate acid. Ammonia is a great example, but we've got some others here as well. Ammonia derivatives or any other cation that came from a weak base. So it's not the weak base itself, it is the conjugate acid of that. The ammonia conjugate acid has the ability to give away its hydrogen. It's an acid, leaving us as just NH3, but most importantly, it's turned into the H3O plus ion. So it is the reaction of our anion or cation with the water molecule that either raises the pH or lowers the pH. So what we're thinking about here is we are looking at the ions in our salt to think about, did they come from something strong or weak? If they came from something weak, then that means themselves they would be able to act as a weak component, weak acid or weak base. It's much less common that you're asked about this, but if both your acid and your base are weak in the initial reaction, they could kind of compete to see which one's stronger or weaker, or to see what the resulting solution is going to be in terms of its strength. But we can even use this in general if we're comparing strongs and weaks. If I put a strong acid, which would have a really, really high K, so like HCl, with something weak, NH3, because the acid is so much stronger than the base, we do end with a solution that's acidic. The stronger of the two determines what our final solution will be. It's not because the HCl is strong, it's because the NH3, for example, is weak, producing a weak acid that then reacts with the water. So when you're asked about this in multiple choice, we can just know, well, a strong acid with a weak base makes an acid. A strong base with a weak acid makes a base. Strong with strong or equal weak with weak is neutral. But if asked to explain why or how it becomes acidic or basic, the reactions are really important, showing how the ion reacts with water to make either hydroxide or hydronium ion. And these examples are great examples of that.